Hello and welcome. I'm Cassandra Lee from Hatch. Today, I'm joined by a true pioneer in electrochemistry, Professor Donald Sadoway, founder of the Sadoway Labs Foundation. Together, Hatch and SLF are advancing breakthrough technologies that are reshaping how industries decarbonize. Our focus today? A powerful concept called Extreme Electrometallurgy, or XE. Let's dive in. Hi, Don. How are you doing?
Terrific. How about you?
Great. So let's start with the basics. What is extreme electrometallurgy?
Extreme electrometallurgy is uh, conversion of various resources, could be primary metals or could be recycling, um, starting with perhaps ore converted to feedstocks, and then the primary evolution of the first metal. And this is done by the action of electric current. So it's electrochemical. And the reason I call it extreme is because this is done at elevated temperatures. And as we know, many of the metals are found in nature as oxides. And that means we're going to have to go to high temperatures. But I don't fear high temperature. I savor high temperature because things move faster at high temperature and we can get higher throughput and and that makes things much more efficient. So that's the in a nutshell what the extreme electrometallurgy is all about. And how is it going to change the world? Well, we know many of the critical, they call them critical minerals, but in point of fact, we don't use minerals in commerce as such. We convert them to metals, and it's the metals that are used in commerce. And most of the metal producing processes are about 100 years old, and they rely heavily on things like carbon reducing agents and so on and so forth. And it's very difficult to practice those today because of the byproducts, CO2, particulates, and so on and so forth. So with extreme electrometallurgy, you're using the electron as a reducing agent. And the electron has no emissions and only comes in one purity, 100% pure. And so that's why I'm very strongly supportive of the use of electrochemical processes over thermochemical processes.
So, Don, let's now talk about innovation. What do you see as the most urgent innovation gap in the Western world when it comes to securing critical minerals?
I think the major gap here is understanding how to invent in such a way that is going to be cost effective when we upscale. I mean, I've seen many really cool inventions that operate beautifully at the lab bench, but when we try to upscale, we realize that there are unit operations processes that are costly, difficult to control, and so on and so forth. So I think we have to invent imagining the endpoint and invent so as to have something that is going to hit the price point that the market expects.
Okay. And how are you using XE to close that gap?
Well, XE eliminates many of the unit operations that we find in classical processes where there's this upfront conversion of ore to feedstock, and then the feedstock has to be purified, and then there are these acid leaching and precipitations and so on and so forth. Whereas XE, because of the high temperatures and the excellent solubility, the solubilizing power, is able to accept. It's more forgiving on the nature of the feedstock. And then by the action of electric current, we can turn dirt into metal and do so in a way that's cost effective.
So let's shift to talk about our partnership between SLF and Hatch. How are we helping clients access cutting-edge XE technologies while managing the risks of scaling from R&D at unprecedented speed?
Well, I think that the partnership between SLF and Hatch is very rich because Sadoway Labs is coming up with bold, imaginative answers to audacious questions. And but when it comes to access to market and understanding how things work at scale, that's where Hatch has the edge. And together we complement each other. So I think that there's a true synergy here that both of us do things that perhaps either of us would do less well operating alone. So I'm very excited about this partnership.
Oh, that's great, Don. It feels like it's a situation where 1 plus 1 is going to be more than two.
You're right. I mean, I know strictly speaking, one plus one is two, but this is a big two in a bold font.
So, Don, before we wrap up, I'd love to hear more of your thoughts on other collaborations. What message would you share with industrial leaders to inspire them to look for effective partnerships between R&D, engineering, and industrial deployment?
I would say, don't try to do everything in house. Play to your strong suit, and partner with people that have the complementary skill sets. And that way, you move faster, and both partners in the relationship are strengthened. So it's if one candle lights a second candle, the first one doesn't burn less brightly. And so people should understand that. And this is a case where I think that Hatch partnering with SLF, it ennobles both parties.
I love those analogies. Thanks, Don. So, Don, where do you see extreme electrometallurgy in, say, 10 to 15 years? And where would you like to see it?
Yeah, well, Niels Bohr said prediction is always difficult, especially when it's about the future. So I'm not going to tell you where I think extreme electrochemistry will be in 10, 15 years. Where would I like it to be? I would like to be pervasive because I truly believe that um, this is a way to efficiently and sustainably convert dirt to metal and answer our needs for these special metals. I'm going to say metals. We start with critical minerals, but it's the metals that we need. And the electron is such a precious and versatile reducing agent that we should exploit it. But we can do so in ways that our people haven't fully imagined. I mean, we were doing stuff like we were running cells at 1900 degrees Celsius. People said this is impossible. We did it, and we could go over 2000, and we could convert all sorts of rare earths, and we get to the near bottom of the periodic table where we have very high melting materials, and it's easy to process them if we're willing to raise the temperature. So I'm that's where I would like to see the field go.
Thanks a lot, Don, for your insights today. Before we wrap up, do you have any final thoughts you want to share with our audience?
Sure. Um, I think it's a great time to be an electrochemist. Um, when I started at MIT back in the early 80s, electrochemistry was looked down upon. Um, the whole idea of extractive metallurgy was considered caveman chemistry, you know. And now it's in the newspapers on a daily basis, and people are asking me all the time, was it, have you heard about rare earths? Have you heard about antimony? Have you heard about titanium? Yes, I have, and I have some thoughts on the subject, and they're fresh thoughts. And it's not going into grandmother's attic and trotting out a process that's been used for 75 years and taking another run at it. It's to reinvent. It's to invent the future, not wait for the future. And the electrochemistry is the key to inventing an exciting and sustainable future. And my message is it's a great time to be an electrochemist, and I'm really happy to be here at Hatch and have this conversation with you, Cassandra.
Thank you, Don, for sharing your insights and passion for innovation. Extreme electrometallurgy is clearly a game changer and is exciting to see how SLF and Hatch are working together to bring these technologies to life. Thanks for watching, and stay tuned for more conversations on powering positive change.